There we go. I just forgot to record. And I'll be sending out the recordings to you guys if you guys want to review or anything. All right. So, yeah. So now what we're going to be looking at is operations. So, have you guys seen these operations before? Addition, subtraction, multiplication?
No,
No?
in other subjects,
Yeah, in other subjects.
yeah, yeah,
Which
I know.
subject?
Maths,
Yeah. So, actually, these operations are literally the exact same as in math. So, like 4 plus 3 is 7, right?
yeah.
2.5 plus 1.7 is oh, 4.2. 1 plus 2 plus 3 is 6. It goes on, right? You can see that we can do addition with both of these different types of data types, right? Or for all of these operations. And what are those operations? Or sorry, what are those data types?
The first 4 plus 3 is integer.
Yeah?
The second one is float, and the
Yep.
third one is integer.
Yep. So we can see that integers and floats can be used for addition, subtraction, multiplication. And also, it looks like if we do integer and integer operation, that results in an integer output. And if we do float and float operation, that results in a float output. And basically, it's like if there's a float there, then the output is going to be float. And if there's only integers, that's when it's integer. So multiplication works the exact same. It's just that we use this special sign to show it. So the way you can get that is if you hold shift on your keyboard and press the 8 key, right? And that will type out that special multiplication symbol. Now, one thing I want you guys to also notice is, did this answer look correct? The 2.7 minus 1.5?
I think is no.
And why is that? Because this is the answer, right?
Yeah, but I guess the answer is 1.2.
Yeah, there's not supposed to be like this many like random zeros and a 2 at the very end. Now, the actual distance of these two, like 1.2 and whatever it gave, they're basically the same, but it's technically not correct. And the reason for that is that these decimal values can be a little bit difficult to store in programming languages. And so there's this thing called floating point error where it thinks there should be too many numbers after the decimal point. Uh, but generally, you just want to ignore that. Okay. So division is where it's a little bit more different. And that's because there's two types of division. There's normal division and integer division. Okay? So normal division, right? You guys have seen it before. Like 4 divided by 2, that's 2. Oh, and quickly, just to note, it uses a slash key for division. So no matter what, normal division will result in a float output, right? These are all floats. Okay? Now, what you can also notice is that like 4 divided by 2, that's cleanly dividing, so you get 2.0. But if it's like a fraction output, then you'll get it in decimals. Like 1 divided by 3, you get 0.33. 5.4 divided by 3.1, you get 1.74. And it just works like that. You can divide float by float, integer by integer, integer by float, etc. But no matter what, you'll get a float output. Now with integer division, it's a bit more interesting. And this one uses two of these slashes, you can notice that. And the way it works is that for floats, if it's at least one float is in operation, it's just the same as normal division. Right now you just wrote like another thingy. So 5.0 divided by 2.0 get you 2.5, right? Exact same. But if it's only integers, then it's something more interesting. So we notice here 5 integer division 2 gets us 2. Is that correct?
No.
No, right?
No, I think no.
Yeah, it's not, right? It should be 2.5. So what's actually
Yeah,
going on here is if you guys remember when we typecasted from a float to an int, it truncated the decimal, right? Like it cuts off everything to the right of the decimal and like it's gone. Now it's like anything to the left so that it's an integer now. So what's happening here is it takes the answer, so 2.5, and it cuts off that point 0.5. It's like I don't want 2.5. I don't like floats. That point 0.5 is gone and now it's just 2. Does that make sense?
little bit.
Yes.
Okay. I think we could use some examples too. So, for example, so first I'm gonna do 5 divided by 2. This is normal division, so what will that result in? 2.5. Now let's try 5 integer division 2, and you get 2. So let's try doing this. Let's do integer version of 5/2. Okay. And now when you run it, it's like the same exact answer, right? And actually, let's do it like this. Let's make 2 variables. One thing I also want to show is that variables can be equal to operations, like 2 plus 3. If we set that equal to var, then that works out to var is 5. Right, just a quick thing. So I'm gonna have 2 values. A is gonna be equal to, let's do 5 for now, and B is gonna equal to 2. So we can print out A slash B. So you can see variables, you literally just think of them as the stuff they represent, right? It's another way of writing, like A in this case is another way of writing 5. If A was changed to 6, it would be another way of writing 6, right? Let's do that, A plus A slash B. Let's print out integer, like typecasting the output, the float output to an integer. And let's try just doing the integer division. So what's this gonna look like? 2.5, 2, and 2. Okay. Now let's try like 6 and 4, 1.5, 1, and 1. So you can see like whatever's to the right of the decimal point, it's just gone. Like it's just poof. It's magically disappears. Python just gets rid of that. And that's how integer division is working. So let's do a practice one real quick. And one thing I'm doing right now is I'm doing comments. So this like hashtag means if I put it before some code, then the code won't run, right? Python's like, okay, this is not code. This is like a comment. I'm not going to look at that. So you see it didn't run. So 7 divided by 3 is 2.33. Okay. What do you think that integer division of this is going to look like? What is 7 divided by 3 with integer division?
2.
2.
Okay,
2.
great. You guys got that. Let's do another one. And if you want to see, that is correct. 9 and so this is equal to 2.25. What is integer division going to be?
2 again.
Yep, that's absolutely correct. It's going to be 2 again. Great. So you guys understand that now. Okay, so moving on. Okay, so division is down. Now we're going to look at something that you guys may not have seen before. That's called modulo. Have you guys seen modulo before? Maybe like
No.
okay.
No.
So, have you guys heard of remainder before when doing division?
Yeah.
Yeah.
What is remainder?
After we divide a number with another number, the remainder is called remainder, I think.
But what is it? It's like the amount left over, right? Like if I had a pie or something, right? And my pie was in like 8 slices and I was sharing that with 3 friends, right? So like 8 divided by 3, right? What would be the remainder there,
2.
right? So 8 divided by 3, like each person will get 2 slices, but then there's two left over that I can't like share equally, right? Well, I wouldn't be able to share that fairly. So two is the remainder, right? Now, what if I had only 2 people to share between? 8 slices and 2 people to share between. What's the remainder there?
0.
Yeah, right. Like it cleanly does it. There's nothing left over. So modulo is an operation that does a division, right? Like 5 divided by 2, um, or something like that, and it returns a remainder after that. So what's the remainder when I do 5 divided by 2?
1.
One.
Right.
One.
The answer is 1. What about when I do 10 divided by 4?
2.
2. Yep. And then you can also notice that if there's a float in the operation, then the answer is a float. But the modulo is always going to return something that looks like an integer, right? Like if it's a float, the value is always going to be point 0 at the end. All right. So does modulo make sense?
Yes.
Yeah.
What is 15 modulo 6?
3.
3.
All right, great. You guys get that. Okay. So it seems like a little weird. Like why would we be using modulo? Can you guys think of any reasons we might want to use modulo? Like any logic or stuff that comes off of it? Looks like no. So how about this? If I have a number and I divide it by 2, what are the possible remainders? What are like number modulo 2? What are the possible like outputs?
1 or 0.
All right. And when is it 1 and when is it 0?
It's 1 when the number is uneven, and it's 0 when the number is even.
Okay. So that means that modulo can be used to check if a number is even or odd, right? Even or uneven. Okay, so that's like a kind of an interesting case. And that helps out because sometimes when you're like writing code, some things only work if it's even, some things only work if it's odd. And modulo is like a really simple way of checking that.
Okay.
Okay, so let's do a check really quickly. What are the values stored in these variables?
A is 5.
A is 5.
A is 7. B is 3. 6 is 12. D is 5. D is 2, 1.5. D is 1, 5. E is
What are E and F, guys? What's the integer division and the modulo answers?
1 and 2.
Yeah. So D is actually 1.67 or 1.66666. But That was close enough. It's some like weird division that you'd have to do in your head, so it's okay. That's a little off. But yeah, those were all correct. Does everyone feel good about operations, or are there any questions? That looks like no questions. So before we move on, um, I did notice that we have some new students coming here today. And so I just wanted to make sure that like you guys are able to be caught up. So for today's class, it's gonna be a little bit difficult because we do have to get through some stuff. Hopefully the review helped a little bit. But by next class, if you guys could kind of look through here, um, through basic data types in the Python 101 thing. So we're probably gonna start getting into conditional statements by the end of today. But if you guys could check out whatever you missed, so that's up to here. That would be great, and that should get you guys all caught up. And were you guys able to do any of the quizzes and like review any of the material?
Yes,
All right. Was it helpful?
that was really helpful.
Okay, that's great.
Yeah.
Okay. So again, like just go through it. There's no quizzes for the stuff we're gonna be covering today, but that's just great if you still want to review. But for any of the people who are coming here like today and weren't here yesterday, be sure to check that out. It'll get you all caught up for tomorrow. Okay, so that's operations. So now we're going to be building like a mini project, and that's going to be the calculator project. So the way I'm kind of setting up this project is like if you were given a problem, like maybe you're taking a computer science class or something, like a programming class, and they give you a problem to solve, then it might be something like this, right? It's going to be kind of vague, and it really wants you to think through how you're going to write the code. Uh, so the first step is that you need to take in two numbers. So they're going to be floats. Remember, they have to be floats. And you're going to store them in variables called num1 and num2. So think about why would you have to typecast? How would you have to typecast the floats? And then also, how would you take in those two numbers, right? What does take in mean? There's a specific thing we looked at before. Then we're going to find the sum, difference, product, quotient, so both normal and integer division, and modulo of the two values, so num1 and num2. And each of these is going to be stored as a variable. So sum is equal to the sum of them, like a variable named sum. Difference is equal to the difference, like a variable named difference, and so on. Then it's going to output those values to the user. Um, so what I'm going to do is I'm going to give you 5 minutes for now. And if you guys can try coding that up, that would be great. And if you have any questions, let me know let me know in private chat in the Zoom private chat. And if you finish it and you think your code is good, send me the code in Zoom private chat so that I can check it. And the reason I'm saying in private chat is so that everyone has a chance to think and that like it doesn't get spoiled, like the answer doesn't get spoiled. Does that make sense?
Yes,
Okay. So I'm gonna leave the directions up here. Let me know let me know if you have any questions and if you need the link, oh, almost there's the solution there. If you need the links, here's Colab again. And if that doesn't work, use Online IDE. Both of those will work for this. Okay, so at like 9:35, I'll check in again. Okay, so it is 35 now. So, nope. Were you guys able to finish writing the code?
Give me 1 more minute.
All right. Do you guys want to spend some time fixing it up, or should we just go into the solution?
Let's go on to save time.
All right. Okay, so looks like you guys did do a pretty good job. It's just a couple things we're missing. So one of them, it just has the input, but remember we also have to find these operations as well. In the other one, we did find the operations, like sum is equal to num1 plus num2. And I do like how you printed out the input given, like that helps the user confirm that that's what they put in. And then we just have to add the other operations, which is pretty simple once we get that part sorted out. You just make a variable and assign it with like whatever this thing is. So like minus sign, that special multiplication sign, slash, double slash, and the percent sign. Also modulo, if you're wondering how to get that, that's shift and 5. Okay, so that's good. But that code does have to, we have to remember that we have to typecast because what data type does input set the values to?
Whoops.
Really?
Yeah.
So if I were to do like, what is your name? I put in Manvik, then the data type of that's float.
No.
Like, what is the default in data type of input?
String.
Yeah, great. So can I do addition and subtraction with a string or other operations too?
No.
No, all right. So just remember to typecast that. So especially you did do a good job with that, but you just have to add the other operations and Rete, you did a good job, but just remember to add the other operations and typecast. Okay, but overall, pretty good job.
Okay, thanks.
All right. So yeah, here's like a complete solution. So we have the typecasting with float. Then we calculate. So you can see it's just like once you get the sum one down, right? Sum and then print the sum. Everything else is quite simple. You just do minus, multiplication, slash, double slash, modulo, and just print it all out. Does that make sense?
Yeah, it does.
All right, great. Okay, so now what we're going to be going over are if statements. So this is when we're kind of getting into the logic behind programming. So we use if logic almost every minute of our lives. So let's look at some examples. So when you get to a traffic signal, like if it's green, then we do what? And else if it's yellow, then we do what? And if it's red, then we do what? Like, what would be the answers to that?
If it's green, we move. If it's yellow, we slow down. And if it's red, we stop.
Yeah, great. So in that case, we looked at some condition, like the color is green, color is yellow, color is red, right? And if that condition is true, if it's correct, then we do some action, right? We go, we slow down, we stop, and like if the first one wasn't true, like if it wasn't green, then we move on to the next one. Is it yellow? If that's not true, then we move on to the last one, right? Something like that. So if statements do basically the exact same thing. And they work by checking if a certain Boolean condition, so those conditions like color is green, color is yellow, that's called a Boolean condition. And it's checking if that's true, and if so, it will run the code inside of them. Okay, so it's a little weird, but we'll dive into it and it'll make sense. So really quickly, a Boolean condition is like that binary stuff we're talking about before. Like true or false, yes or no, one or zero, right? Correct or incorrect, right? There's two things. So Boolean has like the proper way of saying it is true or false, but really you could think of it as like yes or no, or anything else like that. So what that might look like is we could have, right, like color is green. Is that true or false? Right? And then if it's true, then it runs the code. So here's an example. That's how a name variable equal to max. And if name equals, so remember how like the equal sign we're using with variables didn't really feel like the equal sign we're using like in math, right? It didn't say like is these two are equal to each other. It was just saying like this is now being assigned this value. This double equal sign does kind of work like the math one. So this is saying, hey, is name equal to max? Like, or is 2 plus 3 equal to 6? Like, is that a true or false statement?
False.
Okay. Yeah, so similarly, is name equal to max? What do you guys think?
I think yes.
Okay, great. And yeah, name is this is exactly correct. Now, what if it was like this? I'll send it in chat as well. But what if his name was that? Oh, wait, can you guys see my screen now?
Yeah.
Okay. Thought it was gone. So here's the solution if you missed that. If statements. And here's yeah. Okay, so let me just write this and we can see that a little better. Right here. So if I have max, then I'll do if name. So like we said, this is true, so it runs this code. Now, what if the name is equal to max with the lowercase? Do you think this will print out hi max?
No, would it?
That's correct, because it has to be exactly the same. Okay? So that's kind of how the conditions work. Now let's dive into how it's actually being written. The first thing is that we have this keyword called if, right? And keywords are special words that Python uses for itself. So like if is one, for is one, things like that. And what it's saying is like, hey, anytime this is there, I need it for some special reason. Don't make any variables called if. So actually we can try that right now. If is equal to like this, we try and like string some random thing. If I try doing this, it gives me an error because if is reserved. You'll see like it changed color. That's what means it's a keyword. So if we don't use that unless we're making an if statement. So we write if saying, hey, Python, I want to make an if statement. And Python's like, okay, I see the if, let's do this. Then you have this as your condition. So we'll look into what the different types of ways we can make these conditions are in a bit. But what your condition has to be is something that results in a true or false, a Boolean value. What are the different options for name equals max? Like, can it be maybe, or does it only have to be yes, no, true, false?
Has to be yes, no, or true, false.
Yeah, it can't be maybe. Like, name is not maybe equal to max, right? It's we know what name is, we know what we're gonna compare it to. It's yes or no. Okay, so that's your Boolean value. That's your Boolean condition. Then you had your condition, and now oh, this colon we use to show this is shift and then like you'll see it on the keyboard. This we use to show that we're starting the action. So what was the action for if color is equal to green on the traffic light?
Continue moving.
Yeah. So what's the action here?
And the code.
Yeah, we're printing high max. So this says, hey, I want to describe the action now. Then what you do to tell Python that the code is inside the if statement, you do a tab. So a tab is like four spaces. Okay, so 1, 2, 3, 4. That's a tab. Or you could hit the tab button. So it says tab on it, and I go four spaces. And any code that is tabbed over after this is going to be part of this if statement's action. So I could add like print high max, and I could do like a print. How are you doing? So now if the name is equal to max, then it will print out all of this, right? It'll do this as the action. And that's pretty much it to it. And if the code is not tabbed, right? So this is not tabbed, and I do print, will this code be in the if statement? Let's see. So if this if statement is true and we do this action, this code prints. Okay, that makes sense. Now let's make it wrong. Okay. So which of these three print statements will print? Like 1, 2, 3, 1 and 2, 2 and 3, or none?
None of them.
None of them will print? And
One
why
Last
of
is
them.
that?
statement. Last statement.
Just the last statement will print?
Because it's not tabbed.
All
Because
right,
it's
so
not tabbed.
it's not tabbed, so it won't print?
No, it's tabbed and it will print.
Okay. So let's see what happens. So it just prints out the last statement. Now let's try and understand why a little bit more. So the code that is tabbed represents the code that will be printed only if this condition is true. Only if this condition is true, this code will be printed. This code is not tabbed, so it's not actually a part of the if statement. And so what this is saying is like, even if this if statement is false, I'll still run this code because it's not a part of that if statement. Does that make sense to everyone?
Yeah, it
Yeah,
makes
it
sense.
does.
Great. Okay. So here are two examples. So we could have an input num and we convert to an integer so we can do this properly. So it's like if num is greater than or equal to 5, then it prints out that this number is greater than 5. And then it prints out have fun. So if I give you like 6, then will it print out this number is greater than or equal to 5?
Yes.
All right. And will it print out have fun?
No.
No?
Yeah.
Why not?
What?
Will print have fun because it's not tabbed.
Exactly. It's not a part of that if statement. So we can see that here, prints out both. What happens if the number is like 2?
Have a fun only?
Yeah,
Will print both.
it will print both? Okay, so you have different opinions. Rex, do you want to explain why it's only have fun?
Yeah,
Why is it only have fun? Why doesn't this number is greater than 5 get printed out for numbers 2?
because 2 is not greater than 4. 5.
So this condition is not true and the action doesn't run, right? Especially, do you want to explain why both of them would get printed? All right, so Rector, you were correct. Only have fun will be printed because this condition is not true, so it won't run. It's like for 3, only have fun will be printed because the if statement does not run, right? So I think this is a good spot to also kind of see what the different operations are. So what are the two operations we've seen so far? Two Boolean operations, the ones that take in some numbers or take in some values, strings, floats, and result in a Boolean, a true or false. Which two have we seen so far? Take a guess. And as a bit of a hint, remember that the operations are always in this part of the if statement, right? This part of the if statement. So what are the two operations? So remember like addition, subtraction, it's that plus sign, that minus sign, right? So what are the two operations we've looked at so far? Any ideas? Okay, so it doesn't look like we have any ideas right now. So the answer was greater than or equal to. This works exactly how it is in math, right? Like, is this number greater than 5 or is it equal to 5? The other one is equal to, so this is exactly equal to the other thing. So the two operations, so we're going to go over all of them. The two operations that don't or that do work with strings are going to be equals and not equals. So equals, like we saw before, like max equals to max. That is true, right? So you'll see it literally says like true or false or something like that. And if I have like John something, then it's false because John is not equal to Mac. And so what this other one is, this not equals to, so it's kind of funny. It's basically saying, is John not equal to Max? And it's like, yes, John is not equal to Max. So what do you guys think this will print out?
It's true.
Yeah, John is not equal to Max. That's true. How about this?
False.
Yeah, Max is equal to Max. He is not, it's not equal to Max. Like, it's a little weird, but I think you guys will figure it out. So the other ones, we have to use a number. So again, what were the data types we used for numbers?
Integer.
Floats.
Okay, yeah,
Integer.
you got that.
Floats. String.
And these ones are going to be greater than, less than, greater than equal to, and less than equal to. Uh, how are this going to work? So let's see. Let's do some examples. Okay, what's this gonna output?
Uh, 5 less than greater than 3 is true. 5 less than 3 is false. 4 greater than or equal to 4 is true. And the last one is false.
Great. What if I had like, well, if you guys want to see, true, false, that's correct. Now, what if I had, what is this?
False
And why is that?
because 5 is equal to with 5.
Yeah, it's not greater than. Okay. So this works like pretty simple. If I want to do floats, I could do that too. So like, what is this gonna print out?
True.
Yeah.
True.
So 5.5 is greater than 5. Do operations make sense? Any questions here?
It's clear.
No.
So remind me again, what are the 6 operations we just looked at? The 6 Boolean operations. I'm gonna have to remember to say that.
Less than, greater than, less than equal to, greater than
Yep.
equal to,
Yep. And
different
two
form,
more.
different form,
Yep.
different form.
Um, and actually we don't say different from, we say not equal to. It's like it's literally just the opposite. Equal to and not equal to. Okay. So yeah, you guys are on a roll with this. So now there's a thing called if-else statements. So this is useful if we want to run some other code for any time the condition is not true. So here's what that might look like. So we take that input, and if the name is equal to max, then we print out hi max. And otherwise, we're going to say, I don't know your name yet, but hello. So if name equals max, print hi max, and otherwise, like the else is like the otherwise, do this. What do you think it's going to Oh, actually, I should probably say this first. Else is another keyword. We see that from the color. And because it's not tabbed, it's going to be like, it's not a part of this first like action of this if statement. It just gets tied in later. So it's like the else. So what do you think is going to happen if the name is equal to max? What's going to print?
Hi, Max.
Is that it?
Yes.
Great. So yeah, the else prints anytime the conditions above it are always like are false. So the way this works is if starts like so full if else statement or like full we'll see in a second if else statement is always started by an if statement like just an if and the first condition and it's always ended by an else and the else runs only when like everything above it the code inside of the else so anything tabbed under the else only runs when all the code above it returns false. So it's like the last case scenario. Okay. Any questions with that? Do we want to see some examples or go on?
Yeah, we want to see more.
Okay. So I guess some examples with that. So have a num is equal to okay. So I'm gonna run this code. Give me a number to put in.
5
Okay. And what do you think is gonna run if I put 5? What do you
equal
think it's
to,
gonna say?
I
Then
will say this number is greater than or equal to 5.
Great. Do we agree?
yeah,
Correct. Another number.
2.
And what's that gonna say?
This number is less than 5.
Yep. So you guys both got it. And then let's do 8. What's that gonna print out?
this number is greater than or equal to 5.
Correct again. So did it ever print out both of these?
No.
No,
No, right? And that's because the if statement goes over like it this is only when it's true, and when everything above this else statement is false is when it prints out this one. Okay, so you guys got that.
Yeah.
So I'm just gonna change it to this. So if I try putting 5 in now, what's gonna happen?
It will print this number is not greater than 5.
Or yeah. Okay. So we got that. Elif statements, like I mentioned before, kind of, they let you consider multiple conditions at once, right? So they let you kind of combine if statements. Okay, so you can see here. If name equals max, then it's going to print out high max. And if that's false, if name is not equal to max, it moves on to the next step. Is name equal to Alex? Right? Maybe it's yes, maybe it's no. If it's no, or if it's yes, it'll print out hi Alex. If it's no, it'll go, is the name equal to Giselle? And if it's equal to Giselle, then it'll print out hi Giselle. If it's not, then it'll go to the else statement and it'll print out I don't know your name, but hello anyway. So you can see like the if, elif, else statement, the full thing is gonna always it's like a sandwich almost, right? So the if's always like the top piece of bread, elif's are the fillings, and else is the bottom piece of bread, right? And we'll look at some examples with that. But basically, very similar to writing the adding the else statement, and in this case we just write elif. Again, elif is another Python keyword, so we cannot be naming a variable elif. Okay. So this just adds another thing. And in this case, remember, else only runs when every single condition above it is false. Okay? So in this case, when will the else stuff run? When do you guys think? When is the else action ever going to run? What conditions have to be false?
If the number is less than 5.
Okay. And what's another way of putting that in terms of like the conditions above? Because that is correct, but how do we write it in terms of this? Like, because remember, both of these have like all of these have to be false. So it's going to be what? It's not greater than 5, and it's not equal to 5, right? Okay, so I think you guys got that. So if I put in 6, what's that going to print out?
this number is not
It's
greater
greater.
than 5 or not equal to 5.
Really?
This number is greater than 5.
Right, because 6 is greater than 5, right?
Yeah,
What about if I put in 5?
This
this
number is equal to 5.
equals
You guys got that as well? I put in 3.
This number is not greater than 5 or not equal to 5.
Guys got that too. I'm gonna add another thing here. So we know what will happen if I put a number greater than 5. Print out this number is greater than 5, and if I put 5, it'll say this number is equal to 5. So what happens if I do something like 3?
It will say this number is less than 5.
Yep. What about -5?
This number is less than 5.
Great. Well, let's go back to what the else statement is. So this is the else condition, right? Remember that the else condition is printed out when all of these are false. So it's not greater than 5, it's not equal to 5, and it's not less than 5. Can you guys think of any number that will cause this else condition to work?
No, I don't think there is.
Why not?
Because there are numbers greater than 5, equal to 5, and less than 5.
Yeah, so no matter what, a number is going to fall into one of these categories, and so this else statement never runs. That's great. I'm going to do one more thing. So say I have these two things I want to check. And also, you don't always need an else statement. You always need an if statement to start it. You don't always need an else statement, and you don't always need an else statement. So if I put 7 in, what's it going to print out?
2.
Huh?
This number is greater
This
than
number
or
is
equal to
greater
5.
than or equal to 5.
Great. So you guys got that? What happens if I put 5 in? Actually,
This
sorry.
number is equal to
False.
5.
What happens if I put 3 in? Let's do that example first.
Both.
What do you think it's going to print out if I put 3 in? Let's try.
I think it's going to be an error.
Nothing.
Nothing, right? No conditions were true, and there's no else, so there's no like backup condition, so there's nothing. None of these if conditions are true. So it moves on, and there's nothing below that, so it just ends the code, and it's like nothing to print out. Right? So you don't actually always have to print something out. This is an example of that. Now let's go back to 5. What's that going to print out?
Both statements.
Both.
Is that kind of interesting? It only printed out the first statement, even though both of these conditions are true, right? Why do you guys think? Why do you guys think it only printed out this first statement?
Because the first one includes the second one. Yeah.
Yeah. Okay. That's the first step of this. Do you want to build upon that more, or should I explain it?
You explain it.
All right. So, like you said, this first one includes it, right? Like greater than or equal to includes equal to. So, remember that an elif statement or like really anything in like the next part of an if statement, like this elif is connected to this if. It builds upon it. The code here only runs if all the if statements above it got false, right? They're all wrong. And if this is true. So we have to make sure that both of those conditions are checked. So is this true for 5? It is, right? 5 is equal to 5. So the first condition is good. What's the second condition? All of the ones above failed. Did it fail here? 5 is greater than or equal to 5. It didn't fail. It passed through. And so what happened is that because it passed through here, what happened is that it says if num is greater than or equal to 5, it is. So let's run this. And any other part of this full if else statement, there's no else here, but like that's the full thing. It's like, well, none of these can have those conditions met because the first one was already met. So I'm just gonna end it. Same way how like an else statement doesn't print all the time, elif also has to wait for the first thing to print. And so actually since this is included in the first one, there's literally 0 cases where this code will print out. So a little interesting. Now, if I did this, if I changed it to if instead of elif, what that's telling Python is this is an if statement and this is an if statement. So with the elif, this is the statement, right? It goes if, elif, 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 else. All of that gets included together. I start a new one by either putting some new code here. It's like print blah, 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 whatever. Or if I just change this to if. Well, you always have to change it to if because that's like shows that the new one started, right? In this case, it's going to say, is this true, right? If so, print this. And this if statement's done. Move on to the next part of code. This is the next part of code. If num equals to 5, it prints this out. So if I put in 5, it will print out both of them. I think that was a little bit confusing. Did that make sense to you guys?
Yes.
Yes.
So any questions on if, else, and elif statements? So it looks like a no. But again, if you do run into any questions, feel free to ask, right? I'm here to help you guys learn. So now let's do a couple of things that I like to call spot the error. So when you're actually programming, you're going to run into errors. You're going to run into bugs, right? Little problems. And you don't want those to happen because problems are bad. And so it's best to figure out the skills to spot those problems, spot what's wrong with code, and fix it. All right? So let's start off with this one. What's the error here? What's wrong
We
with
need
this?
else. We need else.
Do we?
I think so.
Okay, that's one idea.
We need else statement.
So actually, we don't actually need an else statement because else statement is optional, right? If is the mandatory one. Like if I want to have an if statement, I need to have if. I can have else if I want, and I can have elif if I want. So actually, that's optional.
Double equal sign.
Yeah. So right now we're using like the variable equals, right? We're saying x, like assign it to 5. We're not checking is x equal to 5. So yeah, we need a double equal sign. How about here?
Indentation space.
Yeah, we need the tab. So actually, you do need instructions. Like it's gonna if you have an if statement with no instructions, Python's gonna throw an error. Because like, why are you having an if statement if you don't want it to do anything, right? That's like useless. So no matter what, you need a tab. So that's the error here. But if you also want this code to run properly, you need that. So you need a tab right here on the print. How about here? This one might be a little harder to catch.
Nothing,
No error? Mhm.
I think.
There is one error. It's a little thing, but goes with the
You missed an
syntax. Yeah?
you missed a colon in the elif
Yep.
statement.
So the elif right here, we need a colon. So this goes with the syntax, like the grammar rules of programming. So there's going to be some rules that you always have to follow, and in this case, this is one of them. You always need that colon after the condition to tell it, hey, after this, I want to write some instructions. Okay, how about here?
No need quotation for a number. B.
Yeah, that's on the right track. I wouldn't say that's exactly the answer though. You can put a number in quotation marks, but what's wrong with that? Like, what's bad about putting a number in quotation marks?
We put in quotation marks. It means it's a string, and a string is a text, so we can't do anything with it.
Yeah. Um, so now it's a string, and like a string also includes like happy, uh, blah, 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 or like question marks and stuff like that, like random stuff. So Python doesn't let you do much with a string, and one of those things is like greater than. I can't say that a string is greater than 5. Is hello greater than 5? Like, I can't do that. So same way Python's like, I can't say a string is greater than 5. So that's the error here. So good job both of you guys. How about here? This one's a bit more interesting. Go back to data types for this one.
We need two backward slashes
Okay, and why is that?
because it's modulo.
For
Oh, sorry? Also, how is it modulo?
we need double slashes for integer division.
Right. So right now, this is gonna result um in a float value. So it's gonna be like 2.5, but we want it to be equal to 2, right? So the way we get that is if we do those double slashes so that we get the integer output. So we chop off that 0.5 and it's just 2. Great. Okay. So that's it for today. And then before you guys leave, as a quick reminder, I'm just gonna show the course like one more time. But so if you weren't here last class, I highly recommend going through this, doing the quizzes, and just reading through the topics to understand what you missed. If you missed some parts of today's class, you can go through here. So I think all the way down to the end of conditional statements is what we're at today. All right, so we've covered a lot of Python so far, and you guys have been amazing at how we've been going through this. So that's great. And then yeah, so be sure to check that out. If you haven't already, also just fill out the quizzes as well. It's great practice. And it gives you some good nice coding challenges or questions to jog your memory. But yeah, so that's basically it for today. I'll also try getting the recordings published and getting you guys a link to that. So if you guys haven't seen it already, like make sure that you've verified with the Robotics Academy newsletter because that's how we send out updates to you guys, and that's how you'd get the recording so you can view the recordings and see what you missed and things like that. Uh, but before we end